Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so today we will be continuing our discussion from the previous class. In the previous class, we have discussed about the unit system, SI unit, and we have also discussed that there are 7 fundamental physical quantities, 7 plus 2, and we have stated that fundamental units also, the SI units, okay, of the fundamental quantities. Today we will be going to discuss the various units that we use in measuring length. So first of all, the first thing that we are going to discuss is what is length, or how can you define length. Okay, so what is length? So let us see what is length. Okay, see, the term length was actually has been defined quite a number of times. Actually, the SI unit of length is meter. Okay, so length, length is a fundamental quantity, and it is actually one of the dimensions with which you can identify or make an estimate about the size of the object. Okay, now the SI unit of length. So if I consider the units of length, okay, so units of length. Okay, so if I consider the units of length, so the SI unit of length is basically meter. So the SI unit of length is basically meter. SI unit is meter. Now, how is this meter defined, or what is the definition of meter? Now, initially it was defined in a way that meter is a length or a distance between two points. Okay, between 2 points, and the points were marked on a platinum bar. Okay, platinum iridium bar. Okay, or you can say also rod kept at 0 degree centigrade. And where is the rod kept? It is kept at the International Bureau of Weights and Measures in France. Okay, so that's an international laboratory where a platinum iridium alloy was taken, and a bar or a rod of that platinum iridium alloy was made, and on that rod 2 marks were given, and the distance between those 2 marks were considered to be 1 meter. Okay, let me here tell you that the platinum iridium alloy was taken because platinum iridium alloy has the least amount of extension with the changing temperature. You might be, one question on doubt might be arriving in your mind, that all you have read about the expansion of objects, thermal expansion, isn't it? So you will be thinking that, say, okay, if I take a rod, so suppose this is a rod, and on this rod you mark 2 points, this point and this point. Okay, now you will say that this rod can expand, isn't it? In summer or with rising temperature it can expand. So with the expansion, these 2 marks will go further away from each other. So the length, the actual 1 meter length that we have taken at a, say, in winter, will be changed. It will increase if we observe that length in summer. Yes, isn't it? Obviously yes. That is why the platinum iridium alloy was taken, where 90% platinum is used and 10% iridium is used, and this alloy has the least amount of expansion with changing temperature. So such a alloy was taken, a rod from that alloy was made, and 2 marks were distinguished on that rod, and it was stated, so okay, this length is 1 meter. Okay, it was defined as 1 meter, and it was universally accepted. So this was the original definition of 1 meter. Okay, however, whatever measures were taken, the rod was kept in, say, temperature controlled room, everything was okay, fine. But even considering all those preventions, all those conditions well maintained, the rod can expand with changing temperature, even if by very little amount also. But for precise measurements or precise calculations, even a small change can cause a large variation. So actually with this definition that we have said that meter was originally defined as the distance between two marks drawn on a platinum iridium alloy rod, okay, kept at 0 degree centigrade. Actually it was kept at 0 degree centigrade, and this was kept in the International Bureau of Weights and Measures, okay, in France. This is the original definition, but later on it was considered that okay, this, even if the 0 degree temperature is maintained in the laboratory, still the rod can expand, because it is not possible to always maintain the temperature at 0 degree centigrade. It can vary. So with that in mind, the length, SI unit of length meter was later defined in terms of the speed of light. Okay, so we know what is the speed of light in vacuum. Okay, speed of light in vacuum, do you know? Yes, you know that speed of light in vacuum is defined as, or given by the value 3 into 10 to the power 8 meter per second. So this is the speed of light in vacuum. Okay, speed of light in vacuum. Light in vacuum. Okay, fine. Now, so you may be thinking how the length, unit of length meter was defined in terms of speed of light. Okay, say, so from this value you can say that okay, light travels a distance of 3 into 10 to the power 8 meter in 1 second, isn't it? So, so if I say that if this length, actually the value of the distance that light travels in 1 second is approximately taken as to be 3 into 10 to the power 8 meter per second. Originally, or very accurately if you are considering, it is not exactly 3, rather the value is something like this, 299,792, it's a long value, 456 approximately. Okay, so this is the actual value, this is not 3. Okay, so from this it was considered that okay, let us not take this value, let us take it as to be 3 into 10 to the 8 meter per second. So this is the amount of distance that light travels this meter in 1 second. Okay, so if I consider this, then can we say that 1 meter distance will be traveled by light in how much second? Can you say yes? It's 1 by this value. Okay, so if I say that the distance traveled by light, okay, if it is considered to be 1 meter, so if I apply unitary method, so this much of meter is traveled in 1 second, so 1 meter will be traveled in, it will be like this something, 299,792,456 in this much of second, isn't it? So if the light is moving through vacuum, then it will travel a distance of 1 meter in the 1 by 299,792,456 of a second, isn't it? So actually the meter was later on defined in these terms, that it is the length or distance traveled by light in 1 by 299,792,456 of a second in vacuum. Okay, so this was defined as the definition, or this was the definition of the SI unit of length meter. So meter was how it was defined. 1 meter was the length that light actually travels in vacuum or in air in this much of second, 1 by 299,792,456 second. Okay, fine. Now, so I hope you have understood the definition of meter. Okay, now if you consider that only 1 unit meter, so is it appropriate to say that the length of a pencil, say if you say that the length of a pencil, okay, length of a pencil is how much? Say 6 meter. Length of a, if I say that the length of a pencil is 6 by 100 meter, or you say that the length of a pencil is length of a pencil is, if you say 0.06 meter. So we are not wrong, we are correct. We are trying to state the length of the pencil in meter, 0.06 meter. Or if you consider any other smaller objects, say length of a very small object, let it be anything, but it is very small. Length of a very small object, say its length is something like this, 0.00005 meter. Okay. So if we are to define if we are to state the length of every object, however big or however small it is in terms of meter, it will be quite odd. Okay. Or if you say distance of a place A to B, distance of place A to place B is, say something like this, 9 then 0, 0, 0, 0, 0, 0, okay, meter, something like this. So in all this, these are nothing wrong, scientifically these are absolutely correct, there is no doubt in that. But is it very comfortable to say or state the length of any object in these terms? No, it is not. It is quite inappropriate, because you can, while you are writing in terms of so many zeros, you can actually miss out one or two zeros, and if you miss out one or two zeros, what happens? Actually you are giving a wrong information. So in order to avoid this problem or overcome this problem, what we have done, we have taken some multiples and submultiples of the unit meter. Okay. So while you are measuring some smaller lengths, objects which are very small in dimension, we do not use meter, rather we use, what are those units? Smaller subunits. So if I consider the smaller units of length, so the smaller units of length are what are the smaller units? Say centimeter, millimeter, okay, then is micrometer, okay, then nanometer, and so on. So these are the smaller units of length. Okay. And if I consider that 1 centimeter, the length of 1 centimeter, do you know how centimeter and meter is related? Obviously it is known to you. So centimeter, if I consider centimeter, so 1 centimeter actually is, or if I say in terms of meter, 1 meter is actually 10 to the power 2 centimeter. Then 1 meter is actually 10 to the power 3 millimeter. Okay. Again 1 meter is actually, in, if I say in terms of say micro, it's 10 to the power 6 micrometer. Okay. In terms of nanometer is 1 meter is equals to 10 to the power 9 nanometer. Okay. There is another unit, it's called angstrom. Okay. So 1 meter is equal to 10 to the power 10 angstrom. Angstrom is, the symbol is denoted like this. You write a letter A with a small circle on its top. Okay. So these are the smaller units of meter that you can use to state the length of small objects. Okay. Fine. Now again, when you are coming to the lengths of say bigger objects, when you have stated the distance of place A to place B, okay, so we can use, instead of meter, say larger units of length, kilometer. Okay. Or when you are saying the distance between one planet and another planet, it is quite inappropriate to mention that length in meter. Okay. So the larger units, okay, so the larger units of length, what are the larger units of length? Larger units that we generally use are larger units. So what are the larger units? Some of the larger units are say kilometer. Okay. Then comes for the measuring the distance of heavenly bodies. Okay, we use light year. Okay, then there is astronomical unit. Okay, astronomical unit. Then there is parsec. Okay, so there are various kinds of units. There are larger units. These are the multiples of meter. Okay, so in order to state the length of larger objects, we usually use this kind of larger units. You know the relation between kilometer? Yes, obviously. 1 kilometer, you know, it is equal to 1 kilometer is equal to 10 to the power 3 meter or 1000 meter. Okay, fine. So do you know about light year and also astronomical unit? So it is not known to you till now. Say light year is actually, how can we define light year? Just say the definition, or if I just discuss it in details. So light year, how light year is defined? So light year basically is defined as, light year, it is not a unit of time, it is a unit of length. So it is a distance traveled by light, distance traveled by light in vacuum in 1 year. Okay, so if light travels with the speed of 3 × 10⁸ meter per second, what is the distance traveled by light in 1 year? We can easily get by applying the formula distance equals to speed into time, isn't it? So light year, so if the distance traveled, how much value is the light year in terms of say meter or kilometer? For this you need to calculate, say the speed of light in, it is 3 × 10⁸ meter per second. Okay, so this is the speed, and how much time we are saying? We are saying that the time is 1 year. Okay, so this is the speed, so multiply by the time, 1 year. 1 year means 365 days. Again, 1 day is equivalent to 24 hours. Again, 1 hour is equivalent to 60 minutes. Again, 1 minute is equivalent to 60 seconds. So this is the calculation. If you do this calculation, you will get the value of 1 light year as 9.46. This value will turn out to be as 9.46 into 10 to the power, how much? 10 to the power 15 meter. Okay, 10 to the power 15 meter. We have done the calculation SI units. So this is in meter per second, this is in second. Multiply it, you get the distance in meter. 9.46 into 10 to the power 15 meter. So this is actually the value of 1 light year. Likewise, you can also get the value of parsec, astronomical units. Astronomical unit, if you see the definition astronomical, what is the definition of astronomical unit? It is basically the distance, it is equal to the mean distance between the earth and sun. Okay, so astronomical unit, okay, you have taken down the definition of light year. Okay, so astronomical unit is the mean distance between earth and sun. Astronomical unit, okay, astronomical unit, it is equal to the mean distance between earth and sun. Mean distance between earth and sun. Okay, between earth and sun. So this is the astronomical unit, and if you see the value of astronomical unit is, it is denoted by letter AU. So 1 AU, 1 A dot U is written like this. So how much value it is? It is 1.496 into 10 to the power 11 meter. Okay, that is the value. So these values can be memorized. Likewise, there is another unit, parsec, and parsec is actually bigger than light year. 1 parsec is equal to 3.26 light year. Okay, 1 parsec is equal to 3.26 light years. Okay, so these are the various units of larger units of length. So I hope the smaller units, that is the submultiple units and the multiple units of meter is clear, and the units that we use for measuring length are also clear. Okay, so today we'll be ending our lecture here. In the next class, we'll be discussing about the units of mass and time. Okay, so till then, please do read well, study well, and if you have any query, please mention in the comment box. Okay, so thank you for watching the video. Thank you. Goodbye.